Hi. First, let me wish you an Happy New Year, and I will make a little summary of a recent publication that has been published in Animals, the wrong assumptions of climate change effect in marine turtle nest with temperature-dependent sex determination. First, let me recall you very rapidly what is anthropogenic climate change. The anthropogenic climate change is a change of climate that results from the increase of greenhouse gas emission, and this greenhouse gas emission makes air temperature and sea surface temperature over 1 degree Celsius above pre-industrial levels, and it profoundly alters the Earth's energy balance. All marine turtles and many turtles are characterized by a phenomenon named temperature-dependent sex determination, TSD in abbreviation. When TSD occurs, the sex of the offspring is determined by the temperature experienced during embryonic development. At the bottom right, you see a graph showing the thermal population reaction norm of sex ratio for Rancho Nuevo Lepidochelys campi. At lower temperature, only males are produced. At higher temperature, only females are produced. And you have a range of temperature where both sexes are produced. When you make the link between TSD in marine turtles and climate change, you see immediately there is a potential threat that only females could be produced in future. This has been proposed first in 1989 by Davenport and enhanced by several authors, Nikolai Mrozowski and Fred Jansen for the first ones. However, to make the clear link between climate change and potential feminization, we must go inside the nest, because climate change, when it occurs, is mainly about air temperature and sea surface temperature. What's happened within the nest? The fundamental mechanism of nest heating is rather different than what's happened for air temperature. Marine turtles' eggs incubate at depths of 40 to 80 centimeters in the sandy soil of the beach. Sunlight brings radiant energy that warms the soil surface. The first few centimeters of soil absorb this energy, and it produces a rapid increase of temperature. This thermal energy is transferred by conduction from more energetic to less energetic neighboring particles. It moves downwards through conduction, which is a slow process. In contrast to heat conduction, energy transport by convective heat transfer goes along with a natural material flow, air or fluid. Let's see how it works with a schematic diagram. The sun brings energy to the atmosphere. This is E1 energy. It goes through cloud cover. A fraction of this energy is captured by cloud cover. A fraction of this energy goes through cloud cover. This is the E2 part of the sun radiation that arose at the soil surface. A part of this energy is re-emitted as infrared. This is the E3 part of this diagram, and this infrared are captured by greenhouse gas. It makes the atmosphere warmer, and a fraction not captured by greenhouse gas is re-emitted to the high altitude. This is the E4 part of this diagram. Due to the effect of greenhouse gas, which are naturally present in the atmosphere, the air temperature increase, and this is a T1 air temperature. You must take into account also wind that make convection between air and soil surface. Within the soil, other mechanisms are at play. So the E5 energy from sun is the main source of heat. It goes through soil by convection and conduction, and it produces the temperature within the nest, the T2 temperature. Here I do not take into account embryonic heating, which is another process that occurs very late in development. Now, let's see what's happened when we take into account the post-increase GHG greenhouse gas, the anthropogenic increase of greenhouse gas. We will compare the left part of the diagram, which is the pre-increase GHG, and the right part of the diagram, which is the post-increase GHG. The energy from the sun, E1, is not changed. The climate change does not change at all the energy coming from the sun. Part of this energy is captured by cloud cover. We will see at the end of the process that cloud cover is normally a little bit higher during post-increase GHG than before. A fraction of this energy, then E'2, goes through the surface. It increases the surface temperature. A fraction is re-emitted, E'3, and the greenhouse gas, which are in higher amount as seen for anthropogenic climate change, traps energy in the atmosphere, so the temperature of the air is higher, T'1 is higher than T1. This is climate change due to greenhouse gas, and a fraction of this energy is re-emitted through the atmosphere, E'4. So T'1 air temperature is higher than T1. But the contribution of T1 to the soil surface is negligible as compared to the sun radiation. Then E5 and E'5 are not so different. The air temperature contribution to the soil temperature is negligible as compared to the sun radiation. The wind increase due to higher amount of energy in the atmosphere. As the wind is higher and the air temperature is higher, it enhances the evaporation at the surface of the soil. This is shown by the little droplets, which are more frequent at right than at left, and then you have higher cloud cover at right than at left. Within the sand, the phenomenon are nearly the same from pre-increase GHG and post-increase GHG, nearly same conduction, same convection, perhaps a little bit effect of sand moisture that is less important due to higher convection and higher air temperature for post-increase GHG, but globally we can say that or the nest temperature will be unchanged, or perhaps a little drop of temperature for post-increase GHG. The thermal processes in sand differ from the atmosphere. This is what we just see. Air temperature often correlates with nest temperature, but correlation does not imply causation. You have a correlation, but this is not a direct correlation. This is through the effect of solar radiation. The proxy-based prediction based on air temperature or sea surface temperature are misleading. Greenhouse gases traps infrared radiation, not sunlight. Higher air temperature increases evaporation. The drier sand has lower thermal conductivity. It reduced heat penetration to nest depths. And there is also a possible buffering or even cooling effect below the surface. As a concluding remarks, we can say that air temperature and sea surface temperature are poor proxies for nest temperature. Sex ratio projection using air temperature or sea surface temperature are biased. Nest temperature depends on, first, solar radiation, which is unaffected by anthropogenic climate change, soil properties, but also moisture dynamics. The key message is that the climate change promotes warmer air and sea surface temperature, but does not translate directly into warmer turtle nest. Understanding soil physics is essential to predict TSD response accurately. If you want more information, more discussion, you can go to see my paper just published in Animals, and it is available in ResearchGate. Thanks a lot, and again, Happy New Year. Bye.